Welcome to DevOps for Defense. This month we were going to have the CEO of Gradle come in and talk to us, but he got pulled aside. He had a commitment in Europe. So we've worked it out. He will be in town speaking to us next month. Really cool stuff that they've been doing. They've got Gradle Enterprise, which gives an amazing amount of insight and analytics into your build process. Root cause analysis. Some of the stuff that I've seen looked really cool. I'm real excited about what he's going to come and talk to us about. So please help us get the word out around town, around your offices. On our little blog there, devopsfordefense.org, you'll find flyers that you can download, just a PDF and print, put up around your office. Please help us get the word out, and I think you're going to be surprised at what you see there. I think it's pretty exciting, some of the stuff that they can bring. So we had to put a new plan in place, and thankfully, Vadim volunteered to step up and do a talk. He's going to talk about life of a microservice at Shipt, and we're gonna see how that works. Some of the stuff that at least I've seen in his presentation look really impressive, and it kind of makes me jealous. So I think we're going to see some cool stuff, and be sure to follow up with him afterwards. As always, we start with our code of conduct. You might be shocked to learn this is an unclassified environment, so no dirty words. Please treat each other with respect and professionalism. Don't talk about your secret sauce. Nobody wants to know it. Do talk about your experiences, your needs, your frustrations. See how you can help others and how they can help you. Help us build this community. And, of course, as always, the guys here at Rocket let us use this place, set us all up for free. Please, please, please respect them on your way out. So, like I said, we've got Gradle coming in next month. Hans Doctor is amazing, full of energy, great presenter, so I think it's going to be a lot of fun there. We have GitLab set up to come in and talk to us about what they're doing in April. So a couple of big months coming up with some really cool stuff. And then still working to get some dots connected for later in the year, maybe the summer, the fall time frame. Get some more big speakers in, talk to us about what's going on in the DoD, what's going on across industry, and we'll be working, trying to get hooked up and set up some events with others like Alabama A&M. As always, I have actually failed in January to make this happen. Too much travel in my life, but I would encourage everyone, reach out. Girls Who Code is an amazing organization. They have a bunch of young ladies who are really excited about some projects, and they just need a little bit of help from talented people to get them started. So please, please reach out. If nothing else, you can set up your Amazon account through smiles.amazon.com to give a small percentage to a charity. Girls Who Code is a great charity that you can sign up for on there. I would encourage you to do that. If you are interested in what we're doing and can't join us, we are now publishing, recording and publishing to YouTube, so you can track us down there. And with that, I would like to introduce Vadim. He's going to talk to us about what happens at Shipt.
Right. Thank you. Thank you, JD. So my talk will be about life of a microservice at Shipt. Shipt is a grocery delivery company, which was recently acquired a couple of years ago by Target, so now it's fully owned by Target. Some of you might be thinking like, okay, this is not defense, it's different. In some ways it is, but I would like to bring up my experience first. I've been developing software for 24 years already. Started doing in the research software world. We were deploying code every 12 months. You don't need DevOps really when you deploy code every 12 months. You just stop doing things after 11 months, freeze the code, spend 1 month figuring out how to put it into production, how to deliver it to your customers, how to do QA and all of that. I was working for 11 years in a DoD, NASA world for SIC and LiDARs. And there we did deploy code again every 6 months. Again, when you deploy code every 6 months, you still don't worry about DevOps as much as when you do, like we are doing, like I'm working now for Shipt for a commercial, where we do deploy code several times a day. Totally different requirements, totally different way of doing things. And at the same time, you kind of have the same mindset, even if you are working for defense world versus commercial. Requirements are different, but still the same mindset of doing DevOps, still the same mindset of doing development. It's just tweaks here and there. And throughout my presentation, I'll try to point out whenever I can where the same principles that we're using at Shipt for commercial world can be applied for defense world as well. And please feel free to ask me questions if you have them. So first step of good software development is planning. At Shipt, we are using Clubhouse. It's very similar to Jira that most of you are familiar with. It's a Kanban flowchart. You create a card in Clubhouse. That starts your development process. You assign it to one of your engineers who will start coding. Good thing about Clubhouse, it has automatic integration with GitHub. So when you create a GitHub branch and change status of your branch in GitHub, it's automatically reflected in Clubhouse. And it has very good integration to email and Slack. Slack is a peer-to-peer chat software that we are using at Shipt. After we have a Clubhouse card, let's write some code. We'll write code, commit it on GitHub. GitHub is great. I mean, what else can I say? You commit code, you open pull request. Then what? The most important thing is that we do require 1 or 2 reviews. We don't allow to get code into production branch without it being reviewed. As well as we do require unit tests. I have more slides about unit tests, but bottom line, always write unit tests with your code and expect coverage to go up. And as well as CI, we expect continuous integration to pass. And at Shipt we use Golang. Very good programming language. It's not known in Huntsville at all. I mean, Huntsville is all C++, Java, .NET. But Go is a great language. If you're starting a new project, take a look. It's worth to take a look. It's especially great for web development, like a back-end web development. So unit tests, I mentioned that we do require test coverage. As any developer would know, it's much faster to write code without unit tests. But at the same time, you will pay for it in the long term. There are no ifs. You either do it right now or you will pay for it later. At Shipt, we require 85% coverage. We use codecover.io, a very good tool, which allows us basically to track code coverage of our services over time, so that we can see if we have drops in coverage and how it affects everything. And our code cover is integrated. So what you see here, that's actually from GitHub page. So you will see coverage after you open a PR, you will see immediately, okay, my coverage is going to go up or down. You'll see it immediately. And you can click on any of those things. It's actually specific to each file in your project. It puts you to the code cover link to see what changed. Continuous integration, another important thing. Most of you are familiar with Jenkins. We started with Jenkins, and now we are moving towards Drone. What makes Drone slightly different from Jenkins is that it's much easier to use. It's much easier to get started. With Jenkins, you have to know Jenkins file, you have to know Groovy, you have to know Java. With Drone, it's all YAML. Very, very simple to get you started. It's not as powerful as Jenkins. There are so many plugins with Jenkins. Jenkins has been around for, 10, 15 years. Drone is fairly new. It's free if you have limited use. Even for enterprise, if you have something like 200 services or something, it's still free. It's Drone.io. Take a look at the website. Again, it's automatically integrated with GitHub. If you get it going, if you run it on your internal services, it's really one button click to integrate it with GitHub. And it will show up in Drone. What you see here is a Drone pipeline. So it's defined in YAML file, build, clone, run a database, do all sorts of different sorts of things. And Drone is specifically built for Docker containers. So for example, if you're building web services and you want to integrate with a database, you add a database container into your drone pipeline. It will automatically pull database Docker container as you specify it in YAML file, run your unit tests, and then it can actually produce Docker files at the end that you will need. After drone is done, after CI is done, now it's very important to push your code into a staging environment. I'm sure most of you have read Phoenix Project. Great book, highly recommend. And don't repeat Phoenix mistakes. Please have a staging environment. And if you are working in a Skiff type vault, try to figure out how to mock anything. In a Skiff vault, yes, you cannot get access to customer data, which can be classified, but you can build mocks of your data. Try to build staging environment out of Skiff. Try to figure out how to mock it, or how to build simulators if you're working with classified hardware. So at Shipt staging, our staging infrastructure matches production. Like you're looking at it and say, hey, well, you don't have those issues that we have in classified vault. Actually, we do, because in production we have PII data, and we are not allowed to copy PII data into staging environment. So what we are forced to do, we're actually stripping out all the PII data while trying to mimic staging to match production, because it's very important for us to reproduce all issues, all the behavior in our staging environment to see what our customers will see in the production environment. Integration tests. So after we have our code and staging, what's next? We have to make sure that, again, remember, after all, we are building just one microservice. With integration tests, we need to make sure how does our microservice works with other microservices in the system. When I started working at Shipt 2.5 years ago, we had maybe 2 or 3 microservices. Right now we have over 50. And number is growing. We are constantly adding new microservices. So integration tests allow us to run tests against our staging environment and make sure that whenever we make a change to one of our microservices, the one that we are trying to modify, it didn't break anything else. So we'll ship their grocery delivery. So we'll create an order, the customer order, and make sure that, okay, it goes through the process, nothing has been broken. We can simulate everything, we can still deliver that order in our staging environment. And for us, it's very important. We're using Slack for everything. It's like internal chat system, but it can be reported into email as well. So all failures are immediately reported into Slack or email. So if something is broken, you know immediately that it's broken. Load tests. Load testing is performed to determine if your system behavior can handle normal as well as anticipated peak load conditions. We use Locust. It's a free tool, very nice tool. It's written in Python, and it allows you to put any number of load on your web services. But there are other tools for sure that you can use. So running load tests, why? First of all, it's very important. The reason for doing that is to allow engineers to sleep better on weekends. That's really the main reason to do load testing. Because for us, most loads come on weekends. That's when our customers are trying to order groceries. Weekends, Sundays. Well, nobody wants to work on Sundays. Nobody wants to fix issues on Sundays. By having load tests, makes us comfortable that with 10x of average production load, our system is not going to break. So that's why we are doing load tests, simply to keep us sane and keep system stable. Continuous deployment. It's a software development practice which ensures that after you put code into production, it actually works. And one of the reasons why we are deploying code every day or multiple times a day is that it makes us very good at it. So like I mentioned earlier, yeah, you can deploy code every 6 months, but then it will take you a week to get your code into production. Because whatever you did 6 months ago, even if you documented, even if you documented it, you've simply forgotten about it. You still need to review documentation. You need to go through the process again. What did I do? Why was it there? Why didn't I document it? Why did my engineers change something? But if you do it every day, that's not an issue. It's a small increments. It's very painful to have those increments. But you go through those pains every day, and it's kind of pain that you got used to, essentially. We are using Concourse. It's a free tool. You can look it up. It's concourseCI.org. What I like about Concourse, it provides easy-to-use process. It provides visualization of your process. Once I click merge to master in my GitHub, it automatically starts Concourse pipeline run. I go to Concourse page and I see, okay, which state my deployment is in. And it goes through pulling up code from GitHub, building it, invoking drone to run unit tests and automatically execute them. In case of a failure, it will stop it. I will be notified. I'll get a Slack message. I'll get an email. Say, hey, your code didn't deploy. Something is wrong. Your unit test didn't pass. And most importantly, it takes several minutes. So those are actually very scary several minutes, to be honest. Because at Shipt, we have about 1 million customers, roughly. So when I push a button to deploy my code, in several minutes, 1 million customers are going to use my code. And yeah, you push a button, you go through and you wait and you say, hey, what's going to happen? So if you think that you got it hard in the DoD world, hey, it's not easy in commercial. Infrastructure as code. That's another very important task. All Shipt infrastructure runs on Amazon Web Services. We don't have any in-house hardware. But it brings its own problems. How do you provision infrastructure? How do I tell AWS that, hey, I want my database, I want 5 EC2 instances, I want my queues, I want my SNS topics, and so on? Well, we developed our internal tool, which is based on YAML file, and it uses YAML file to convert it into Terraform script. You might not be familiar with Terraform, but what Terraform does, it has its proprietary script which automatically builds infrastructure for AWS, Google Cloud, and Azure. And there is a new alternative to that which is called Pulumi, which actually allows you to define your infrastructure in one of the three languages, Go, JavaScript, or Python. So what you do with Pulumi, it's a really neat tool. You can check it out on pulumi.com. You just write a Python script and say, hey, I want an EC2 instance, I want some Postgres database, I want whatever. And then push a button, Pulumi will do it for you. And you can come back to your Python script, modify it, because your requirements change. You want another instance. Another push button, you got it. Very handy. And it's different from running your on-premise hardware when you need to order it, wait for 6 months in order to get it on site. Now, services in production, are we done? And that's the last step of DevOps. It used to be up to here, and now observability comes into play. You want to make sure, what does it do in production? You want to find out. So it all starts with error monitoring and crash reporting. We're using Rollbar, which is just a handy tool where all of our microservices report data whenever something goes wrong, as well as all crashes. Typically, they don't crash, so. But you never know. But critical reports are critical errors and crashes are reported to Rollbar. And again, another important thing is that we're immediately being notified by Slack and email. All our queues have alerts to be attached to OpsGenie. There was a presentation 3 months ago here about from Atlassian. OpsGenie is an Atlassian tool which we use extensively. So it is connected with our Slack alerts and other alerts. Again, if you write a defensive code, whenever you expect something goes unusually wrong, then you're supposed to report it to Rollbar, and then it will be connected to OpsGenie and Slack alerts. Observability. That's outside of just crashing and error alert, there is an observability task. That's a task of finding out what does your application is actually doing in production. And observability consists of three main tasks. It's tracing, which is request scoped, metrics, and logging events. And I'll go into details into each one of them. But most importantly to realize, you have to have all three. It's not just one or two. Because they provide, while they do intersect, they do provide different level of understanding of what your software is actually doing. And it really doesn't matter if it's a web service or desktop application, because you just apply different principles, but it's still the same thing. So let's start with metrics types. So we have container and service level metrics. All of our services run on Kubernetes, which report data to Prometheus and ended up in Grafana dashboard. What Grafana dashboard is just a bunch of nice graphs. So if you hear the word Grafana dashboard and you never heard of it before, it's just a bunch of graphs, that's all. And Prometheus is a way to store your data. And all of our microservices refer data to hosted graphite. Again, it's just fancy word for storing your data in a database. So container level metrics, those are the metrics and telemetry that come from your container directly and from your hardware. This data comes from Amazon load balancers, Docker containers, and Kubernetes tools. It tells, this is, by the way, this is Grafana board. So you can, as you can see here on your Grafana board, you can see memory usage. You can see, what do I have here? Number of connections and response time. But typically that you will get CPU, you will see your memory, you will see your network usage. Whichever you can get out of Docker container, that's what will be container level metrics. Service level metrics are a little bit different in that those are the metrics that are reported by the service itself. That's what your engineers have told the service to report. Those could be business level metrics. For example, number of orders were created or number of feature XYZ being created. It can also be latency data because services typically have a way to measure the time from request comes in to the time that response was sent to the client. It also can be like number of calls to the data store, which is usually very handy because you need to know how long does it take you to access your database. That's usually the slowest part. That's why you built into your service latency measurements for your data store access. And again, the same Grafana board. And you will see what you have with metrics. You have timing data, telemetry data, and you will see how it changes over time. And you can say, hey, what's happened last month? What's happened last week? What's happened last hour? So during outages, that's why you look and say, hey, what did go wrong? Why did I have a number of calls go down or up or whatever is going on? Next one is logging. We're using Scalar, but Splunk is doing the same thing, and there are various other tools on the market that are doing that. Logs are typically taken from containers to downstreams or output files, and they're combined into a tool like Scalar or Splunk, basically for searching. So your container is supposed to output those tools, your service, your reverse proxy, your gateway, they all will be outputting those logs, and then you use tool like Scalar or Splunk to search over those logs. Again, if you have an outage, if something is broken, you go into that tool or similar tool, whichever you are using, and just search and see, okay, what happened at that period of time, why my service is crashing, or what's going on with my application. And always ask your engineer, so if you're a developer, ask yourself, write log as much data as possible and try to put different levels of logging. So if you can put info debug levels, that will allow you to enable or disable logging if you need to fix an issue. And last one is tracing and distributed tracing. We're using Honeycomb for that. So what is trace? Trace represents a single user's journey through the entire stack. It can start from a front-end app, and then it goes, it hits your gateway, and it hits your multiple backend services. And then you can see it on a trace. Okay, what's happened essentially? Okay, it's here's my service one, and then that service accessed another service. And then we have calls to data store and another data store and so on. It allows you to track inefficiencies in the system and understand how your services actually interact with each other. And there are multiple tracing tools. This is just Honeycomb trace, but there is New Relic, there is Lightstep. There are so many of them on the market, which provides basically a UI to see how request goes through your system. And finally, closing the loop. It's very important to learn from failures. At Shipt, whenever we have an incident, whenever something goes wrong, and something always goes wrong, we have no blame postmortems or retrospectives, where we provided timelines of the event, of what's happened, and we try to learn of what was wrong. And again, very important thing, it has to be no blame. We are not going to blame an engineer or site reliability or whoever person was to, there is most likely there was somebody responsible. But if you'll try to have a blame somebody culture, then people will try to hide information from you. That's why it's very important to have a no-blame culture, because only in a no-blame culture, people will be honest, and then you can actually have truly honest action items. And then, again, it will generate your new Clubhouse cards, and then you can restart the process again. And finally, always dedicate time to repay tech debt. Your product manager might not like it. Product managers always want new features, but yeah. Oh, I started my. That was my first slide. So Clubhouse is similar to Jira. It's basically. All right. So yeah, always dedicate time to repay tech debt. So that's all I have, and basically we went through the whole thing of this loop. So Clubhouse was planning, code GitHub, building with drone, testing was done in drone as well. Then the release was with Concourse, and deployment was on Concourse. And then we talked about operation and monitoring with different logging metrics and tracing tools. And now we are back to planning. So, any questions? Thank you.
Thank you. That was great. All right. So, you saved my bacon on a short week to with a unplanned guest rescheduling. That was really awesome. So, for the people that work with me who've been saying that guy's crazy, we can never run microservices and you can't build pipelines that automatically provision and deploy. He does it, so I think we can do it. So as always, we like to point you to some resources. I did add one, start over here, a book that I read over the last probably month or so called Team Topologies. It's a really cool book if you're looking at how to optimize your organization or define your teams. It has some incredible insight just in terms of how people communicate effectively. It's a really cool book, so I've added it to our list here, and I would recommend it, especially if you're thinking about organization and how to get your teams aligned better. And as always, we end with a lean coffee. Actually, if you were here in December, was anybody here in December? We got some December folks. Awesome. Did any of you pick up the book, The Unicorn Project? So if you would, I would love to have the book club session here. And then everyone else, welcome to come to a lean coffee table. Lean coffee, if you've never done it, is a ton of fun. Great way to kind of get to know other people and talk about things that matter to you. My suggested topics are completely worthless because they were for a different presentation that I put together before he showed up and said, hey, I got a topic for you. So make up your own stuff and go from there. So that is our meetup. Thank you guys for coming. I hope you really enjoyed it. Stop by, say thank you to Vadim for talking to us and telling us about what he does and see what we can learn from him. I think there's a lot going on out there in the commercial world that, whether we like to believe it or not, directly applies to our work. And we have a lot that we can learn from people like him and how to improve what we do. So with that, thank you all for coming out. I hope you enjoyed it. Meet up with some new folks, do a lean coffee. If you read the book, please hook up with me. Let's do a quick discussion about the book and what you thought, what you learned, what you didn't learn, and we'll go from there. So thank you very much.